Alrighty, partitioning. So, why do you want to partition? Well, your schemas really might be excellent, but at some point in time you might realize that your data set is just so huge that even a query that uses the appropriate indexes and is optimized just takes tons of time. One of the biggest benefits of using the built-in partitioning in MySQL is that it does partition pruning. So you might hear that a lot, or you might read it in the manual. And basically all that means is that nothing's actually pruned. It's just what to look at is pruned. So nothing's actually deleted when you talk about partition pruning. It's just the fact that if you're doing, let's say you're doing a count of everything between two dates, it's going to know which partitions it doesn't even need to bother look at if you do that. Traditionally, you might use merge tables to do kind of a hacky partitioning, but MySQL doesn't really know, doesn't have a sense of which data is in what partition in that kind of way. With actual partitioning, it knows. So it can do this partition pruning, and it won't actually scan partitions that don't have any matching values. So partitioning, what is it? Well, it can be used to describe many different ways of splitting up the data. Some people talk about partitioning among different machines. Some people talk about partitioning your data as in, your user data goes here and your other data goes there. So you're kind of splitting up the data. But when we're talking about partitioning here, we're talking about the same structure, the same schema, and actually the same table, just it uses partitioning. So that's the built-in function for tables, to split up their data kind of into, you can think of them as subtables. And how is what we're going to go through here. Basically, you can specify that a table is partitioned. It's part of the table create statement, so you can alter the table and add partitions, things like that. But it's on a per table basis. So, how to partition. In your create table statement, here's your create table, table name, field type. At the end, I didn't put the engine or default car set or whatever, but you can have that. And it's basically partitioned by type, and then you have a field or list of fields, or actually an expression, and then the partition information. The neat thing about partitioning, other than the fact that it actually has knowledge and can do the partition pruning, is that unlike, say, merge tables, it works with most storage engines. I have a list that we'll go through in a second of which ones it does and which one it doesn't. There are some limitations too, so we'll go through those as well. It can't actually be used to partition on different servers. It does not work with federated. So if you have data on two different servers, like if your data set is just so huge that you need it on two different servers, you can't do that. You can actually specify it to be on different disks, which we'll go through. And basically the part info there changes based on which kind of partitioning you're using. And we're going to go through the 4 different kinds of partitioning. So, partition definition information. Basically, you can have 1,024 maximum partitions or subpartitions per table. The partition names, which, let's see. If I click there. See that's in the partition info. In some partition types, you can specify names. They're case insensitive no matter what operating system you're on. And you can actually use a function instead of a field. So we'll talk about range partitioning in a second. But instead of partition by type field, you can actually do partition by type expression. So with the functions, they actually say that they've optimized the partitioning in MySQL for the year function and the to_days function. You can use any function. And I don't know what they mean by optimized. For some reason, it just is faster, I guess, than if you just did the operation itself. Now, this is another point. Whatever you're using, if you're using a field or you're using some kind of expression, that can add overhead if you're adding an expression. So again, if you have some kind of table that's doing thousands of writes per second, you might not, this kind of partitioning may not be the right solution because you may be doing so many calculations on that data that you're inserting that it might not work out very well.
Can you describe it as a way to kind of, especially if you have timely data, separate the two?
Yes, it is a way to separate timed data. If you have like logging or whatever, not the internal table logging in MySQL, because in MySQL 5.1 you can actually log to a file or log to a table. But if you have, say, I've actually done this with Apache logs, where you can use mod log SQL or mod SQL log, whatever it's called, where you log the Apache logs to an SQL table. I've actually used partitioning on that kind of a table. And you can do neat things, like you can actually drop a partition. So if you have that kind of thing where you're like, oh, I really don't care about last year's data, let me drop the partition. It's a lot faster than delete, even with an index.
Can you export a partition?
Can you export a partition? No. But it does use partition pruning. So if you do like select into out file using the right, using the right where clause, then it's going to be faster than having just a regular table. So let's go on to the requirements. So you can only use an integer or a null field in the type. We were talking about the field or the expression. So basically the expression has to come back as an integer or a null, except in the key type. But we'll go through all that. The partitioning function can only use fields from the primary or unique keys, which means any field that you use in that partitioning expression has to be in the primary key. And it's not that it has to be in either a primary key or the unique key or any unique keys. It has to be in the primary key. If there is no primary key, it has to be in unique keys. So basically, any ID that's used, if you have a field in both, or if you have a field that's in a unique key but not a primary key, you still can't use that for partitioning. We'll go through more examples later, so if you have questions, you can ask now or later. And the partitioning function can only use, yeah, that's what I said. So you have this error, which I think makes it a little more clear. A primary key must include all columns in the table's partitioning function. So it's kind of easier to say it in that if the primary key has to have any of the columns in the partitioning function. I was kind of saying it backwards, where all of the things in partitioning have to be in the primary key. All right, so here's some of the restrictions, and some of you may leave after seeing the next few slides. For example, you can't use a table that has a full text index partition. Okay, not the end of the world. No spatial data. Okay, not the end of the world. Not very many people are using spatial data. But no tables that use foreign keys or are referent in a foreign key. So if you refer to a table in a different foreign key and you refer to this table, you can't partition this table. That's kind of a showstopper for some people. That's one of the limitations. That's really a difficult thing.
So it's sort of a standalone table.
Yes, yes. And it can be a logical foreign key, but not an actual EnoDB foreign key. A lot of people have kind of logical foreign keys if they are not using EnoDB or if they don't want the overhead of having to look. So you could still use it, but you can't have a foreign key on the table, and you can't have a foreign key to the table.
Is that a MySQL specific restriction, do you
Yes, that is a specific MySQL restriction. I think it probably has something to do with indexing and checking, having to check all the things and having to check multiple partitions for data to see if that data is there would be complicated. That's my guess. Partition definition restrictions. So it works for all tables, all storage engines except for temporary, merge, federated, and CSV. But it works for archive, it works for EnoDB, it works for MyISOM. I'm not sure if it works for Falcon and or Maria. Does it work cluster? Yes, in fact, cluster is actually based on partitioning. Cluster wouldn't be able to work if there wasn't partitioning. So you can't use any tables that are used for internal logging. So when you set your logging to, if you set it to a file and you also set it to a table, like the slow query log or the error log, if you log those to a table, you can't actually partition that table. Which, it's kind of like I would want to be able to do that because that's, by date or whatever, but I guess I can understand. It's not the end of the world. You could probably have a trigger on a logging table, if you can do triggers on logging tables, and then insert that information into another table, which then partitions it. We can do lots of hacks with MySQL. And you can't have a key cache for that table. Yes, there are more restrictions. You can't use insert delayed on a table that has a partition. And, I guess I can kind of see that. You don't want to have to deal with where do you put it when you insert delay. I think this is a MySQL 5.1 thing where you can actually specify the data or index directory. It might be a 5.0 thing or a late 5.0 thing, where on a table you can actually specify where the data is and where the index file lives. That's actually ignored on the table level because you can actually specify it on the partition level. So that's not really necessarily a bad thing that you can't do that, but it's important to know that if you do it, it will just be ignored in the way that MySQL likes to ignore things. And you can't use MySQL check or MyISM check on that table. Here we go, range partitioning. Basically the type that we talked about before is just going to be range. You specify values less than. So you start with a range and you say, okay, values less than this number are in partition, the first partition, which you can name. And then values less than. So values less than 10 are in partition 1. Values less than 20 are in partition 2. And you don't have to say between 10 and 20. You just have to say less than. So, and then you can also specify the partition names. So that gets us to our first example, or at least our first sample text, which is, here's our create table, table name, here's our fields, partitioned by range, and here's our field or our field expression. So we have a partition p name, values less than val, and then you can add more. You have to do this in order, right? So you can't say values less than 20 and then values less than 10. So I made a little example here, and here it is. So create table nums range ID, here's the primary key, engine, partition by range, and basically we just have this list of, if it's less than 1 million, it's in P0 mil. If it's less than 2 million, it's in P1 mil. If it's less than 3 million, fine. And if we do a select min ID max ID from nums range, we can see that we go from 1 to 4,393,163. One thing that you can do is if you wanted to drop all of the data that's less than 1 million, you can actually alter the table and drop the partition. So if I do something like alter table nums range drop partition P0 mil, and it's going to take a while. There we go. Oh, 0 was affected. Now the minimum ID is 1 million, not 1. So now I've just deleted all that range, and if I actually use the delete statement, it would take a lot longer.
Is the definition of the partition gone? So if you added something under 1 million now?
Yeah, the partition itself is gone. So now if I added something under 1 million, it would go into the 2 million range. So if I do insert into nums range, I think it is, ID values 1, it says 1 row effective. If you had something outside the value, like let's see, 6, 1, 2, 3, 1, 2, 3, you get this table has no partition for value 6 million, because there was nothing greater than 5 million that we actually specified. So also when you count ranges, it's a lot faster.
And you can ignore the partitions and just use the table and count across all the partitions?
Yes,
I guess that's what you do.
query it like a regular table. You actually can't really specifically say use this partition. You can actually find the minimum maximum values. You can look at the information schema.partition, which is kind of neat. And we asked, what about a value greater than 5 million, and how can we fix that? So select, I'm just going to do this, table name, partition name, partition, ordinal, position as pos, partition description as DSCR, table rows from information schema.partitions, where table name equals nums range. Okay, so basically we have 4 partitions. We used to have 5, we now have 4. And here's the description, is that it's 2 million, because it's values less than 2 million, values less than 3 million, values less than 4 million, values less than 5 million. And here are the number of rows in each one. It's kind of odd that it has more than 1 million in here. There shouldn't actually be more than 1 million in any of these. But these numbers also may be approximate because it's using ENODB underlying. So information schema, metadata is usually approximate for that. So the way that we fix this is by having a values less than max value partition. So we could say, oh, let me have all my partitions, but not values less than max value. I actually have a special table that I used here called show create table nums range max. If I did that right, there we go. And so this is basically the same thing, although the partition does have P0 because I didn't drop it from that one. Partition P4 is values less than max value. So I think in this one I had P4 being 5 million. So let's see what that looks like in the information schema. Okay, here we have 0, 1, 2, position 1, 2, 3, 4, 5. So we have these rows and we have the max value. So if I now do like insert, well, let's see, it should be back here. Yeah, into nums range max. Now it says okay, one row affected. So there isn't the problem where we had with nums range where it said outside the bounds of the partition. There's no partition for that value. Nums range max, because it used that max value, didn't have such a problem. And this is actually the definition. Nope, that's not the definition. I must have changed it. Anyway, I kind of went into the next example here too, which is the fact that you can actually use an expression. So now I have nums range mod where the expression is actually ID modulo 4. Instead of modulo, where the values are less than 1 million, less than 2 million, I basically just have partition 0 is values less than 1, partition 1 is values less than 2, partition 2 is values less than 3, blah, 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 and partition should be empty is values less than max value. Because there should never be a modulo 4 that's greater than 3. And so we can show you there nums range mod. This is the same thing that I just showed you. But if we look at, say, well, let's do this first. Select min ID max ID count star from nums range mod. So I only put 500 in here because making data tables with 5 million rows was getting took too long. It took like 3 minutes to create on my computer. So I was like, well, 500 is enough. So the minimum ID is 1, the maximum ID is 747. There were some numbers that aren't represented. So here we go. We've got 0 has 125, 125, 125, 125. Max value, so it should be empty is 0. And again, the description is this is values less than. Values less than 1, values less than 2, values less than 3, values less than 4, and then values less than max value. So yeah, you can use any expression in that partition expression. We used modulo. There's a list of expressions that you can use, like you can use absolute value, you can use a lot of stuff. There's a lot of expressions you can't use, and you can refer to the manual page to see that. But as long as you use something that's an integer or that will give you back an integer or a null value, then you can use it for range. And you can use any, in the values less than, we have values less than 1, values less than 2. You don't have to use a number. You can use an expression as well. Again, as long as it resolves to an integer or whatever. As long as it can be used in an expression of is x less than expression, then you're okay. So it's actually quite powerful.
I'm sorry if this is redundant with the restrictions at the beginning. I don't remember them all.
Yeah.
You can have regular indices on.
Yes,
tables?
you can have regular. In fact, this table has a primary key already.
I'm just thinking if you've got an index that searches something that's not the primary key, so it's just going to go all over and search all the partitions, and you won't get any performance benefit necessarily?
Right, because to partition, all of the fields that are used in the partitioning function have to be in the primary key.
Right, so if you're searching or using an index that's not part of the primary key.
Right. Then it's not going to use partitioning, and you'll still get the value of the index, but the partition key is faster, especially like we said when you're doing stuff with dates and stuff, when you're really, that like you're really looking at the first part of the table. For these numbers, for instance, you know, there's one table that's modulo 4. So maybe I know that I'm always looking for the things that aren't divisible by 4, that are divisible by 4, the even numbers that aren't divisible by 4. You know, so I've done that. But, you know, if you're doing it by, like the first one I did where you have numbers less than 1 million, you know, then you might know that you're searching on those specific ranges more often.
So if you have composite primary key and you're just partitioning by one column.
As long as it's in the composite primary key, it doesn't have to be the first. It doesn't have to be the first column in there. For example, well, let's try it, right? Create table composite primary key test. So let's say ID int, and then like I mean it has to be a number, right? So let's say
They both have to be.
foo int bar int primary key ID foo bar, and let's say partition by range.
In this example,
Foo.
try not including bar. That could actually also have just a...
Okay. So one question is, does it do this? And then we need partition 1, you know, or like P0 values less than 10. Just trying to make sure I'm actually defining it right, because, you know, it's not like I know the syntax off the top of my head. Partition P1 values less than, let's say, max value. Just because it's always good to specify that catch-all case. And I didn't do it right. Partition by range. Oh, because I have to actually close the... I have to do this. So, for instance, here, if I wanted to say, like, engine equals, you know, enodb, I could do that. That's where it goes. Okay. So, so is that all you wanted to know?
Well, I'm just wondering, so now we have our B-tree primary index,
Right.
clustered index over ID and foo,
Uh-huh.
and yet well, I guess it's, and InnoDB stores data in that clustered format,
Mhm.
right? However, we've just partitioned by, it just seems kind of strange, like what's mysterious to me is like, how is the data going to be stored now?
It's going to be stored in clustered primary key order within each partition.
Okay.
Could you have partitioned by the full primary key?
Yes. So let's do an alter table comp PK test. Partition by range ID foo. And then let me see if I can just copy and paste because I'm lazy. That was the same bad table I just had. There we go. Drop table comp PK test. And then that goes there. Now what did I mess up?
Well, how can you apply a single int to two
Oh
values?
yeah, I would have to like add it together or something. You can't do it. It has to resolve to an integer or a null value. So I'd have to do something like that. A no table, right? It didn't drop the table because it didn't have one. So yeah, you can use more than one. You know, and you could say the natural log of foo to the power of ID if you really want. It doesn't matter. It has to resolve to a number. So there's also list partitioning. List is like range partitioning, except that you don't specify that the values are in something. You don't specify the values are less than something. You specify that they're in a certain list, which makes more sense for something like the modulo example I had. Also integers, also null. That's how you specify partition by list instead of partition by range. Partition by list expression. Partition name values in list. The order isn't important. There is no catch-all. That's important. There's no catch-all, so you have to catch every single one. Again, with our modulo example, here's our modulo ID, modulo 4. It's a lot easier, right? We are catching every example. There's no problem with it. and we have partition 0, values are 0. Partition 1, values in 1. Partition 2, values in 3. Partition 3, values in 3. Seems pretty straightforward once you get range down.
What do you think I'll catch?
Then you get that error of, well, let's go here. Let's see, show, create, table. So here we go. It's called nums list mod, and it indeed has all this stuff. I could drop a partition, alter table, nums list mod, drop partition 0. And we need to insert into nums list mod, ID, values 4. And it says table has no partition for value 0. So that's what happens. I picked a particularly really good function for using list, which you should, right? If you really are going to need a catch-all, you want to use range or one of the other types. You know, the list is really for something where you only have these values, and that's it.
So what about, so an empty partition is not going to cause any problems?
Nope. In fact, I can add that partition back if I want. I think I can add a partition. Can I do add partition? No, I can't. I can't really do that. Maybe I can. Let's try. Values in 0. I don't think it's going to work. You can actually add partitions for other types, but I don't know if you can. Yeah, you can't. Add partition.
The order is not important then.
Well, the order is not important in list values anyway. Oh, that worked. So you can actually add a partition back. So now if I do, if I show things from the, here we go, nums list mod. So if you see, here are the partition names, and here's the order now, right? The position of this is 1, 2, 3. The position of 0 is actually in position 4. But it doesn't matter. And it has 0 table rows. So there's no problem. It's just going to make your table definition very long. But there's probably better ones to use because you want it to be self kind of monitoring. So if you use something like a hash value, the hash value will just make the new one whatever it needs. Well, you actually specify how many partitions to have. So we will certainly go through that in a minute. So one thing about range and list and any kind of partitioning, if you're inserting a value, if you're inserting many values and you insert a value that doesn't work, so like let's say you have, let's drop this partition again. And let's insert this again, right? So we know that this won't work, but let's say we have like values 1 for 2. Except that's not really going to work because I think I already had those duplicate key entries there. So let's say 4001, 4004, and 4002. Now what happens here is it says there's an error that the table has no partition for value 0. But what it actually did is it inserted this value, 4001, sometime, there we go, 4001, but not 4002. Because it does what MySQL does all the time with it. If you did like an insert ignore into, then it would have inserted both, but it did not. It only inserted that. So if I do select star from nums list mod where ID is greater than 4000, we should only see 4001. And in fact, oops, that's not all we see. 4001, it should accept 4001. Oh, I think I might have, there might be some kind of transaction thing going on there that I have set. It should actually do that, and the manual actually says that when you do this, yeah, delete from nums list mod where ID equals 4001. That's odd. Well, that's probably a bug. It should insert it, just like a regular statements. So if
Maybe
you...
it's an all or none thing. Why don't you try just inserting 4001 and do the select?
Okay. Oops. Yeah, but what I'm saying is it shouldn't be an all or one thing.
Yeah, but it looks like that's what it is though.
Right. But that's not what it's supposed to be. That's not what it's supposed to be according to the manual and according to how insert works with everything else. So this is either a, hey, the manual's wrong, or hey,
Right.
there's a bug. So anyway, that what I just said may or may not be true about insert statements. But basically, if you're doing bulk insert of stuff, don't count on any one type of behavior if you've used list or range and not specified the catch-all for range, or if you haven't specified anything if you haven't specified everything for list. So just be careful when you're using list. Very careful when you're using list. Insert ignore should work fine.
Oh, that's so different.
Let's try.
Can you combine list and?
So, in fact, it says duplicates 1, which is fascinating. Because there were no duplicates, right? So if we delete...
Yeah, 4001 is in there.
No, I deleted it.
Oh, you did?
I thought I did. Let's try it again. I think it says duplicate because that was the one that had the error. But look, I've definitely deleted it now, right?
Yep.
So there's definitely nothing in there now. So now we do, duplicates 1. So by duplicates, it means we didn't insert that one. It doesn't actually mean it's a duplicate. It means there was an error and we didn't insert it. So MySQL is assuming if there's an error and we didn't insert it, it's because it was a duplicate. Yeah. In fact, that was not the case. So that's all for list partitioning. Are there any questions before we move on to hash partitioning? All right. Hash partitioning, again, what should you partition with hash partitioning? You can actually do an even distribution with a hash partition. So if you just want it to be kind of more even, you're not necessarily doing it by ranges or doing it by a list, then it will just be kind of an even distribution. That's what you can do with the hash value. You specify the number of partitions and you specify what to partition. So basically the partition statement is much simpler. Partition by hash, here's the partition expression, partitions x, where x is a number of how many partitions you want. You have to make sure that the expression here has the same value, that it's deterministic, otherwise your hash is going to be way off, because your hash won't actually include things of the same value. For example, if your hash, the hash function is, say, a modulo function, which it actually is. There's 2 different ways you can specify it, but one is regular. When you specify like this, it's a modulo function, right? So if you have, something modulo 4, no matter what, 200 modulo 4 is always going to be the same thing. It's always going to be 0. You can't use an expression that gives you things that don't do that. For example, you can't use rand with ID as the seed, because it's going to get a different one each time, and you're not going to get a good hashing function. A change in the column value should correspond with a change in the hash value. So for example, modulo actually isn't a good expression to use, because if the column value itself changes, the expression should change. So if you use, say, a floor or a ceiling expression, that's also not good in this hash partitioning thing. Because basically what you want is you want it to be able to hash it, and then it's going to put, if you say 2 partitions, right, it's going to hash it, get a unique value for that particular value, and then it's going to put it in one of 2 partitions. Which, if you know how cluster works, it's actually very similar to how cluster works. The way that the hash expression actually works is that it actually does a modulo. So, you do have to get, again, same with list and range, the expression has to give you back a number. And all it does is it determines which partition to use by doing modulo partition. So if you say 2 partitions, it will say, put this in, whatever number you get back, modulo 2. I think the expression is better when you're only doing it on 1 table column instead of more than 1 table column. The more complex the expression, the bigger performance hit you're going to take. That's kind of, I don't know why they specifically said that with the hash as opposed to the other ones, but. So the hash partition definition, again, much cleaner. Create tables nums hash, ID, int, whatever is my primary key, engine equals NoDB. Partition by hash, ID, partitions 4. So I decided that I wanted 4 partitions because, 4 is a nice, easy number. So if I do schema for nums hash, I think I still only have 500 values, and again, I have, 1, 2, 3, 4. Just put it in there, into that. So what happens if I decide, oh, there's way too much data and I want it to be in 5 partitions in the hash instead of 4 partitions? Well, I can do alter table, nums hash, partition by hash ID, partitions 5. And that had to go through all 500 rows and now do, okay, now I just modulo 5. But now if I look, now there's, if you notice the description is null, that's because we didn't have to specify values in. We also didn't have to specify the partition name. So this is a question somebody asked before, do you always have to specify the partition name? We didn't. It gave the partition names of P0, P1, P2, P3, P4. So, and of course, it names them with 0, 1, 2, 3, 4, and then it numbers them in the position, in the ordinal position, 1, 2, 3, 4, 5. Right. So the question is, do you have to partition by something you would query on? Well, the answer is, why else would you partition? Although that's not necessarily a silly question, because you could just have tons of data, and if you just have the tons of data, you just need to partition it because it's too much data to have in one, file or something. Then yeah, you can use that. And again, you do have to use any fields that you use in the partitioning have to be in the primary key, or if there's no primary key, the unique key. So.
Well, that actually, I was thinking about your yearly data thing, because that relates to something I'm doing. So in order to get the benefit from that, assuming that's how you want to partition, that would be your primary key, one would think. But you're going to have tons of redundant data, so it can't be your only primary key, because then you can only have one entry per year, and it becomes useless. So how would you set up a partitioning table based on year, or some sort of ID that you're going to have multiples of?
Okay. So let's say part year test. Let's call it TS date time, and we'll just say it gets timestamps, right? And then let's say user ID int or something, because you wouldn't just have that table stamp, or if it's some kind of logging table, there might
like
be
an Apache log or something, whatever.
Right. So an Apache log would have refer. Let's say varchar, I don't even know what it is, but let's say, then URI varchar, let's say 50. And then we're going to say the primary key is going to be, let's say, URI TS refer. And then we're going to want engine equals my isom, just because we really don't want that primary clustered key, it would be too big. And then we would want to partition. Now, actually, what I actually like to do when I'm partitioning is to just let me create the table first, then worry about the part. Just because there's so much to the definitions. I mean, the hash definition is a little different, but there's so much to the definitions that I like to, and especially since I have syntax errors all the time. So partition by. So one of the ways you could do it is say partition by range, where you do year of TS, right? And then you would say partition P0 values less than 2008. Partition P1 values less than 2009. Partition P2 values less than max value. Look at that. So now I said at the beginning that actually the year function and the 2_days function, 2 days. So if we do say select 2 days of now, that is actually optimized in the partitioning function. So it's actually set up so that you can do that year and have it be like that. So does that answer the question of how you might do that?
It does. So you make a primary key of more than just what you want to partition by.
Right. And you don't have to, it doesn't have to be the actual year itself that's partitioned. So you don't have to worry about like, oh great, now I've got to, get that year out and have it as a separate column as year. You don't have to do that. As long as the time itself is somewhere in there, you're fine. Any other questions?
Can you give partition names that would sort of indicate
Sure.
I mean, so
So-
you could say P,
So I could say,
or values less
right,
than 2009.
bigger than 2009, let's say.
Right, or something like that.
And then I think you can actually use numbers, because this basically, partition names, other than the case sensitivity, basically have the same, excuse me, it has the same, less than 2009 actually, because it's 2008 and everything below. It actually has the same restrictions as other identifiers, like table names, object names. So you can't, for instance, use when. Well, I guess you can't use a number. But I bet if I did like P 2009, that would work.
Right.
If you were slicing this out by year, you probably wouldn't use the range, you'd use the list.
True.
Right.
Yep.
Range would probably be more valuable if you were going to group years together to get a partition.
Yep. So, we could say, hey, let's...
The rules for the names will be like a directory of file names.
Yeah. So, well, first of all, if I do something like when, right, which is a reserved word, it won't like that. So let's do this for now. So now all I'm doing is just saying in and in, because that's how you specify the list. And getting rid of the catch-all because there's one. Yeah, I can't use when. So you can't use reserved words. I think you can use them if you backtick them. Again, just like other identifiers. Yeah, but again, probably not the world's best idea. So I think that's actually probably why you can't use a number, because it parses it as a number. Like if I really wanted that, I could probably do this. Yeah, it parses it as a number. If you use a number, it thinks it's a number as opposed to a table identifier, or a partition identifier, name. So if you actually wanted to specify, like if I do this, it won't like 2009 because it's not escaped, it's not quoted. So it's like, oh, there's a number here. I don't understand what this number is doing here. But if you escape it with the backticks, it says, okay, no problem. And now if you look at the information schema for part year test, and we could see that the partition name is actually 2008-2009.
But in the directory where the file tables are we going to see the one file or multiple files?
That is a great question. User local, MySQL, to become root here. So we're actually in the part DB. All right. So here you go. Here's your partitions, right? You've got a data file and an index file for each partition. And you've also got a .par, which has the metadata for the table.
To get the best performance, if you had a history of queries against a large data set, and you wanted to determine what was the best method to use to split up the data so that you can make best use of the query.
You would have to look and see, just like when you have like an index, right? You're trying to index and you've got 3 different queries that use similar indexes, right? Maybe you have one query that uses an index, so you decide you want an index of 3 columns because one query uses all 3 columns, one query uses 2 columns, one query uses... In the same way, yeah, that's exactly right. You would look at your queries, you would see what is the best key to partition on, maybe what the most frequent query is, what takes the longest.
Split it up amongst a number of partitions. So
Right.
that you would parallelize it.
Right, whether you want the year, or maybe you don't want to split up by year. Maybe you want everything that happens, between 8 p.m. and midnight. Any fields that you use in the partitioning expression have to be in the table's primary key, and if there's no primary key, it has to be in the table's unique key. So that kind of limits what you can use to partition. But yeah, you would have to decide, do you want to partition by date? Maybe you want to partition by month and year. Well, how are you going to do that? Well, you have to concatenate the two and say maybe 2008-01, because then that's a number, because you have to use a number or null.
But how do you take, let's say, a bunch of queries that you may have for a few months or a year, and now the challenge then becomes to look at those queries, and how would you actually look at those queries and split up your data so that...
Get a consultant.
Get a You can actually,
That's, right now, I think that's the best way because.
well, a consultant, well, that's a good answer. A consultant, for example, might know how to use tools such as MySQL SLA, which is a statement log analyzer, which will aggregate up. If you guys have ever used MySQL dump slow, which takes your slow query log, and it says you have this many queries for this, this kind of query happened this many times with an average time of this. And there's actually the statement log analyzer can do that with a general log or even just a list of queries, and it can do it with a whole bunch of different things. So that's actually at I think hackmysql.com. So there's actually MySQL report is pretty good too. Basically MySQL report gives you some basic tuning stuff about your server. Now MySQL SLA, if I go up here, it's also got IDX check, which I think this checks for duplicate indexes. So MySQL SLA parses, filters, analyzes, and sorts MySQL slow, general, binary, and micro slow patch logs in order to create a customizable report of the queries and their meta property values. So they do have a documentation, but they do have a guide. I mean, it's a Perl script, so this might look like it's really complicated. It's just a Perl script. You can actually even do wget this, which I will do live here. Basically, I think the answer you're looking for is if you need to partition, you probably know what you need to partition on. You know what I'm saying? I think the only time you'd be in that predicament is if you have two things you probably need to partition on, and they're mutually exclusive, like somehow having to do both the year and a user ID or something. But you could put those together, right? You could say a year, that's always 4 digits, so the first 4 digits is going to be, concatenate the year and the user ID. And so, the first 4 digits are going to be the year, and then the next are going to be whatever. So.
Right, but as time goes on, there'll be fewer queries for older. There may be fewer queries for older years.
Right, and you can drop those partitions after you can archive the data and drop those partitions. One of the things also is that MySQL has the partition pruning, which basically means it's not going to scan partitions it doesn't use. So if you're saying, well, what about the older data? Well, that's the whole benefit of partitioning is that if you say where the year is, 2010 to 2015, it's not even going to look at the partitions for 2008, 2009, and 2016.
One interesting thing I saw was you could actually select different engines for different partitions, right?
Yes, you can,
So,
which is neat.
sweet.
Yeah.
Can you associate a partition with a directory?
Yes, you can. The question was, can you associate a partition with a directory? And the answer is yes, you can. And I will show you how to do that later.
Well, just one comment to that then is if you were to create a partition where you split things up, say, in range of time during the day, you could then associate that with different directories. Then as you're scanning through those partitions, you can use multiple disk drives.
Yes, and then it would be a lot even faster because you have different disk drives.
And then you wouldn't have to worry about what month or year, it's just basing on time of day.
Right, and in fact, you could probably do something where you have mounted, not that MySQL and FS play well together, but you could theoretically mount the directories and then just not have, you can drop the partition after you've, unmounted the disk or whatever so that you can actually, keep that data. That's kind of hacky or whatever, but yeah, that's another way to improve performance is you're reducing disk seeks by having different partitions on different disks, especially if you're doing a lot of inserting too. I mean, if you're doing a lot of inserting and you have it partitioned by year, then everything that you do right now is going to be on the same disk. But if you have it partitioned by, say, user ID, it's going to spread the writes across all those different disks. So again, there's many different reasons to partition as well. It's not necessarily just reads or anything like that. So that was the hash partition definition. Now there's something, we talked about the fact that the hash partition uses modulo. There's also something called linear hash, which is like hash, but instead of using the modulo function, it's a more complex algorithm. And I can show you what it is if you really want. But it's, let's see, you take the log of base 2 of the number, you take the ceiling of that, and then you take 2 to the power of that. So the example in the manual they give is like, let's say you have the number is 13. The log base 2 of 13 is 3.7004 or whatever. The ceiling of that is 4. And then the power of 2 to the 4 is 16. So that's going to end up being the number that then gets moduloed by the number of partitions. So it's a little crazy. And the reason that you would use that instead of hash is that adding, dropping, merging, and splitting partitions is faster. The disadvantage is that you get less of an even distribution because you're doing this weird, pretty much because you're using a ceiling, right? Because anything that you take the logarithm base 2 and then 2 to the power of that, it's really the ceiling function that's doing that. We started with 13 and ended up with 16, right? So anything in between kind of, I think, probably 8 and 16, it's going to end up being 16. Anything greater than 8 probably will end up being 16 because you have that modulo where it's just kind of grouping them together by powers of 2. Here's linear hashing. It's called a linear powers of 2 algorithm. And here it is. And here's the example I just showed. So, and I have to imagine that this function has more overhead than a simple modulo. This is my guess. But here you're doing 3 different functions on one thing. You're doing power, ceiling, and log, whereas modulo is just modulo. Okay, so, and again, it's the same thing as hash, you just put this linear word there. Now let's talk about key partitioning. So key partitioning is very much like hash, except you can only put a field or fields in there. You can actually use non-integer or non-null fields, so you can use it on a car field if you want. And you have to use part or all of the primary key. Again, I'm not quite sure why the manual said this when they said it has to be in the primary key anyway. Maybe they meant order or something. They didn't specifically say order. They did specifically say it has to be part or all of the primary key, but so does regular ones. So if you can actually not specify a field with this one. For all the others you have to specify, let's see, something like expression, where the expression has a field. You don't have to actually even specify an expression here. If you don't, it's just going to default to using the primary key, all the fields in the primary key. And if there is no primary key, then it's going to use a non-null unique key. And if you try to define it on a table that doesn't have a primary key and doesn't have a non-null unique key, it's then going to give you an error. Which, of course, now you want me to try out. Because I didn't even understand what I just said, maybe. So if we do create table, let's see, key test 1, and let's say pi car 2, partition by key. I think we actually have to specify open close paren. But let's try this. Yeah, no, we do have to do this. And it says field in list of fields for partition function not found in table. Because it can't actually, so if we do not null unique key, this should actually work. And that did work. So this is actually slightly misleading because the field was found in the table, it just wasn't found in the primary and or non-null unique key. So if I drop table key test 1, and I don't specify not null, if I allow it to be null, it should give me the same error it gave above, which is, again, kind of a misnomer of an error because the field is there, it's just not null. It just is allowed to be null, and therefore it can't really be, a primary key can't be null. In fact, if I do this, it'll probably say that I have to specify not null for a primary key and not even get to the partition definition. Or it just knows that primary key is not null. Key test 1. So here, yeah, it actually put not null in for me because I said primary key. So I didn't actually specify the field, but it put in the primary key or the not null unique key. Okay, so we just showed you how to use it, partition by key, and you don't have to even specify any fields. Partition X, it uses an internal algorithm, and basically I'm just going to read right from the manual. So what's this internal algorithm? Well, for cluster, it's MD5. So what it says is partitioning by key is similar to partitioning by hash, except that where hash partitioning employs a user-defined expression, EXPR, that we've been using here. The hashing function for key partitioning is supplied by the MySQL server. So the hashing function itself is whatever on the columns. You can't use a part of the columns. So for instance, you couldn't use year of the timestamp for this one. MySQL cluster uses MD5 for this purpose. For tables using other storage engines, the server employs its own internal hashing function, which is based on the same algorithm as password. You know, the password function. So, would have been nice if they used like a standard kind of hashing function, but oh well. I guess I can't complain too much. So it is storage engine dependent, and actually really it's kind of NDB versus all other storage engines dependent. In 5.1, cluster actually became its own package release, so it's really kind of server dependent, whether it's cluster server or something else.
What version did partitioning come on the scene?
5.1.6. So now we have the key partition definition, which we did. We already showed you this, partitions X. It's very much like, and you can actually specify the fields in there if you want. Let's see if you can actually specify more than one field, because we saw that we could not in the other ones. So let's drop that table, and let's do this. So we're going to want hi car2, ID int, and then like primary key ID hi, partition by key hi ID. Let's see if we do that. Ha, and we can. So what did I want to show there? Oh, that you could use 2, which you can't do if you're using like a hash function, because it has to be a number. I'm just doing hash because it's, if I did range, I would have to specify partition by values or whatever. So yeah, here it doesn't like this, ID. It doesn't like the comma there because that's not a number. So for key, you can actually do that kind of thing. And I think the reason that you can do it is the same reason that you can use car2. I think it just concatenates it together, the ID and the primary and the both fields. If you've ever had a problem with like replication where it says, oh, there's a duplicate key. If you have a composite duplicate key, it'll have like field 1 dash field 2, and it's actually a string. I think that's what they're doing here. So we also have a table for this one, and it's called nums key. And again, we have the similar kind of key. Show create table nums key. It's very boring. We just have partitioned by key, partitions 4. And again, you have, a bunch in each one. There is also, just like there is linear hash, there's also linear key. And it's a similar thing. You just put in the word linear here, and it uses that same power of 2. So it actually does the same modulo 2. So those 4 types, range, list, hash, and key, are the 4 types of partitioning. So if you had a table with, say, a timestamp and you wanted to use the year function on that, what do you think the best one to use would be? There's no necessarily right answer. I mean, obviously, if you're using a function, you can't use the key because you can only use columns, right? But there's There's hash, list, and range. What do you think you would use for that? Who knows? Range?
You use range if you don't need to crop and add. There's a problem with that.
You'd use a range if you didn't need to crop and add?
Sorry, drop.
Oh, drop and add.
Yeah, we ran into a problem where we do this for data marts, but they drop them of data. Now I want to add that again, you can only add to the end.
Right. When you add a partition, you can only add to the end.
So for management, I would use list or something like that rather than range.
Okay, right. And then, of course, there's the kind of added benefit that if you don't have the right table, if you don't have the right partition, it's going to complain that you don't have the right partition, as opposed to if you use range and use a max value, you're just going to end up with everything in the right thing. Now, granted, you may not want that to happen because you don't want to be woken up, at midnight on, January 1st, 2009, midnight 01, or midnight and 1 second by your paging system going, hey, there was an error in the error log. But that's something to take into consideration. There's problems. Some people might say, well, I want to use hash because it's just using modulo, and I could specify 10 different ones. So I could say starting with 2000, I could say modulo 1, 2, 3, 4, whatever, modulo 2000 or whatever I want. Only because that's somewhat self-perpetuating with the partitions. So it won't actually create more partitions, but if I say modulo 10 and have 10 partitions, where 0 through 9 is each in its own partition, then I don't have to worry when the next year comes that I have to actually maintain it. Whereas with list and range, you have to maintain it. So there's pros and cons of using all three, and that's why I wanted to let you know there's not like a right answer. There's pros and cons to all of it. Really, what you want is something that will say group all of the same values together and make a new partition if one doesn't exist. And that way, if there was some magic partitioning function like that, then you could say just do it by year, and any new year you find, put a new partition in. That's probably potentially dangerous for somebody that accidentally does timestamp as their thing, and that's probably why it's not an option. But I think Oracle and or SQL Server has such kinds of things where you just say group them all by this, and if there are extra ones, then make a new partition for that new value. Okay, so now we're going to get into something that we were talking about before, which is being able to use more than one hash type. So there's composite partitioning. So composite partitioning, you can have subpartitions. So you can actually partition your partitions. You can only do this, so you can only subpartition partitions that are the range or list type. And you can only use the hash or key type as your subpartitions. Is that clear as mud yet? It's okay, we have examples. So, for example, we'd like our nums table here. Here's our nums composite table. So we have taken our partition by range. So now I've actually added a happened date time because, it doesn't make sense to partition twice on the same field. So now I've actually have a date time, and I say, okay, I want to know partition by the range, the hour when it happened. Now, previously I might have something like if the value is, less than 10 or less than 20 or less than max value. So then you subpartition by the hash of the ID. So now it's kind of like when you order, you can order by one and then by the next. Same kind of thing. You partition by the hour and then you subpartition by the hash. Now this is the reason why you can only use hash or key because as the subpartition, because you don't actually specify the different numbers of partitions for that. You specify the numbers of partitions, but you don't specify how. So now I've said, okay, I want 2 subpartitions for the hash. Partition P0, P1, and P2. So these kind of correspond to the range. Then you have subpartitions too. Now, I can actually specify subpartitions 2, partition P0 values less than 10, subpartitions 2, partitions P1 values less than 10. The caveat is you have to have the same number of subpartitions for each one. So let's see what this looks like on disk. Well, let's see, show create. Well, you just saw the create table. So yeah, let's see what it looks like on disk. Local MySQL data, part DB, ls, what do we want? What do I call it? Nums composite star dash LRTH. Let's see if that does anything. Oops, I have to put a space there. So I have a composite and then a .par. Well, that's interesting. Here we go. Oh, comp pk test. No? Composite. Let's see. Show create table. NUMS composite. Did I do this wrong? Oh no, the subpartitions are there. I guess you just don't see it on the in there. Let's see what it looks like in the information schema. So here, now we have two partitions with the same name and the same partition, right? But they have different number of table rows. So actually, this might be a job for selecting star from information schema.partitions, because there's actually a lot more in there, and it's going to actually look really bad. But the things I do for you. So table catalog, null, table schema, part DB, nums composite, partition name. Here's the subpartition name. So P2, SP1. Whereas this one here was...
You probably could see the subpartitioning name by appropriate select.
Yeah, I just didn't know exactly what I was looking for. So we can do partition name, put subpartition name. Get rid of the partition ordinal position. Maybe there's some other things we want to put in here. What else do we want to put? We don't need the subpartition ordinal position, but maybe the subpartition method. Oops. That's P name. Actually, we don't need the table name at all. Almost there.
Change that one.
Yeah, the other two. Well, as S name. The subpartition method as method. Like you could see that this is so very, there we go. So now we've got these two, right? P0, SP0, and it automatically named these names, right? Automatically named the subpartition name because that's hash, so we'll automatically name them for you. Now the method is all hash, even though the range, right? Here you have description 10, 10, 20, 20, max value, because that's the subpartition method. The partitioning method is range. So this is actually a little odd to see. Again, I don't have exactly the right columns here, but you can see that it's actually split up into the subpartitions.
You said the subpartitions can't be an integer, they have to be varchar?
No, in key, okay, in hash, range, and list, they have to be either integers, so the expression has to evaluate to either an integer or the value null. In key, it can be anything. So this is kind of a way to do it, to subpartition on more than one, which might answer your question that you had before on the how do you decide what to do. Well, here maybe you don't have to decide, But again, it's like sorting. You might sort by, say, country and then by city name, so that Boston or whatever state and then city name. So Boston, Mass, and Boston, Texas are two different locations, and you kind of see it that way, as opposed to city name, ordering by city name first and then by state name. Similarly, which you partition by is really important. If you partition by year first and then by user ID or whatever we did here, nums composite is by ID and then by happened. So we're doing it by the ID first, which since ID is an auto increment, it's probably actually a better idea to partition it by time first, and then partition it by the ID.
So the rule for subpartition is followed for all the partitions, so it's the same?
You have to have the same number of subpartitions. I believe, and we can try this out if you want, I do believe that you actually can specify more than one type, so you can have key for one and hash for the other. But let's try that. So if we do create table.
Okay, I guess there isn't a problem unless...
It's no different from having a regular table on a separate disk, or an InnoDB table space on a separate disk. The same considerations, yeah, you do have to worry about it. No matter what backup solution you're using, if you're using cold backups, which is stop the server or lock the table somehow that they don't write, and then copy files, you have to make sure to copy all the files. If you have triggers, you have to make sure you copy the trigger files too. So you can't just copy like MYI, MYD, and IBD. You have to actually copy everything in those data directories.
So if you have replication, is it exactly the same partitioning?
If you have replication, is it exactly the same partitioning? Yes, because alter and create statements are replicated. But if you do something like set SQL log bin 0 and then do a change thing, then you can theoretically have different partitions on the master and the slave. And in fact, you might want a black hole table on the master and a slave which is partitioned for like a reporting server. Or you might want to drop a partition on the master but leave it on the slave, because your master has a lot of live data. So you'd set binary logging to off by doing set global SQL log bin equals 0, and then drop the partition on the master. It doesn't drop on the slave, and then you have less data on the master and all your data on the slave.
Just make sure you don't have a typo.
That's true. Yeah, that's the thing that I don't like about SQL log bin is that you can't actually check that it's set. It's just like, okay, well, it didn't come back as an error. Fingers crossed. So, alrighty. Partition maintenance. We already saw alter table. So you can alter table, rebuild partition, which I did earlier. That is used for like defragmentation. What that does is it takes the partition, it takes all the data out of the partition, and rebuilds that partition with all the data that's supposed to be in there. So it's not going to lock all the partitions, but it is going to scan all the data in the table to see which data goes into that partition. So that can be used for defragmentation.
So it scans the whole table, but only rebuilds that partition.
Yeah, I mean, it probably scans any data that is in like less than max value. Like I don't know if it does any partition pruning like that, but you know, how else can it do that? Similar to like, you know, when you rebuild an index or whatever. This actually has something rebuild versus optimize. With optimize, it actually reclaims the space. So it actually kind of drops the partition and reclaims the space, whereas rebuild partition just rebuilds it. Doesn't actually drop and build again. It just, however that works. I don't know why they felt the need to have both when they don't for like tables, but you know, optimized and analyze and rebuild. But rebuild drops and reinserts entries, where just the entries, whereas optimize drops and rebuilds the whole partition. But it obviously doesn't drop it, because dropping it would drop the data, so it drops the partition.
Bounces.
Yeah. Otherwise, rebuilding would be really simple, right? Drop and rebuild. Oh, look, there's nothing in there. So partition maintenance, you can also do check, repair, and analyze, which do similar things for check table, repair table, analyze table. So analyze partition reads and stores the index key distributions for the partitions. Repairing, so we saw actually that each partition had its own MYD and MYI file. So again, it has its own index for itself, even though it's an index across the whole table. It actually has its own indexes.
Is your execution plan going to be different for each?
Could be, I guess.
It's gotta be, right?
Well, I mean, it's not that it's different. It's the same execution. Well, I guess it depends on how much data. If it's not even.
All of your partitions, you could have different execution plans.
You're on my next slide. Is the thing. You don't have a different. I don't think you necessarily have a different execution plan if the partitioning is even. But I could see how you might have use a different index if the partition is not even. However, there's actually an explain partitioning that you can do. So just very quickly, check partition checks for errors in the same way check table does. It'll tell you if data or indexes in the partition are corrupted. And if they are corrupted, then you would use alter table repair partition, and you could say P0, P1 to do two partitions. And then analyze reads the index distributions. So you also have this explain, instead of explain select, you can do explain partition select. So, you know, explain partition select star from nums range mod limit 10, and you can see it's actually going to look through all of these indexes. Now it's interesting that it looks through the should be empty one, but it does actually look at the type, and it does look at the keys and stuff. But you can't specify different indexes for different partitions.
No, but I'm just wondering if you can analyze each partition.
You
And
can.
one of them comes up with some very different statistics.
Yeah, that's a good question. Would it change the execution plan because something only has, say, 3? Like it wouldn't be a full index scan, but a full table scan or
Because
something.
it's basing index choice on the cardinalities, so if they're radically different, I'm just thinking because each index is now separate,
Right.
so
Well,
your execution plan
Yeah, one of the problems is you can't actually use explain extended and explain partitions at the same time. So you might be able to see that if you saw explain extended, but you can't. And let's see, if you use explain partition select on a different table that's not partitioned, you don't get an error, you just get partitions null. And the rows is the total number of rows in the table, not the number of rows scanned, which would obviously be 10 in this case. So there's that, and then the next slide is, you've got the manual, you've got forums, here's the manual link. No, here's a manual link to the limitations that it has, but basically I think it's partitioning overview.html. As we saw here, I think it's chapter 18. Hello. Oh, I have to do this, I bet. Yeah. Yeah, chapter 18 is partitioning in the manual, but that could change. And that's all I have.
Okay, so,
Where's the clapping, please?